All right, we're going to do a similar screen share. Let's get right into it. And so our goal for this one, let me see, whoops, that's not what I want. Our goal for this one is to try and understand this type of plot. And we see that there's a single slit effect, and we notice for a standard double slit, we see the pattern of fringes with nearly identical brightness, but then every once in a while, one of them is extinguished. Like right here, we see that the single slit minima quenches or extinguishes the double slit pattern. And so we see the double slit pattern, we expect them to all be equally bright, but the single slit is called an envelope function. So that's the envelope. And so how do we make this type of plot? That's our goal. All right, so, and let me, whoops. Let's clear those annotations and let's get to work. So if you haven't followed along with the previous video, you should probably do that first, where we figured out this one and got all that done. Remember, and that shows you how to label these things and name your constants. Notice I've named this new constant D for the slit width. All right, and whoops, this is going to be now phi. Letter F in the Greek font, symbol font. All right, and so notice the equation we're using is very similar, only now we take the single slit equation, which was this was the single slit intensity pattern, and then we also scale it according to what we expect from the double slit using this result. And that's all you have to do. So if you want to pause the video or erase me, go ahead. I'm going to clear my annotations and get to work. So this one should equal 2 times pi. Notice that 2 is in there this time. Pi is a function, include those parentheses, times d over lambda. And again, if you don't know how I got these constants to pop in there, just watch the previous video where I forgot to multiply by sine theta, which is right here. So having some extra columns just makes this kind of handy. Fill that down, and then this should equal the single slit times cosine of phi, and then I guess I'd better square that, squared. Now we can run this down, and if I want to plot this, I can highlight the angle. Oh, I want to show you something that I forgot to say in the last video. Notice you get a divide by 0 here. So we know from experience this one should equal I max. So you could just punch that in directly. Remember that that was how this was defined, and the issue you get is a sine of 0 over 0. The computer doesn't know how to do L'Hopital's rule here. Maybe some more advanced program might. And Microsoft Excel doesn't have a sync function in it, which is what this is. This type of function is called a sync function. You can Google that. Anyway, so sometimes you have to manually type in a number like that, so just be aware of that. Let's clear out those annotations. And let's get to the plotting. So what I'm going to do here, whoops, let's go up to the top. I want my angle in degrees, and then I want the intensity pattern of the single slit, and then I want this pattern. So what I did, maybe I'll say this again just in case you forgot. Hands off the keyboard, hands off the keyboard. Highlight the angle first. Now press and hold Control. I'm still pressing and holding Control. I have not let go, and now I'm going to get this column. And you have to get those in one swoop. And now I'm going to insert charts. And there we see this thing. And now we're going to have to do some of our usual cleanup. All right, so maybe we'll go like this. Format axis. This is going 0 to, let's go to 100. And then maybe we want to go let's see, so, oh, that's fine. Let's go here. Let's just do 0 to 90 so we can see it a little bit better. So we could start to see the pattern in there, and maybe we should only go to 10 degrees so you can see it. Oh, we see this weird numerical artifact. What's going on there? What's happening is the pattern is changing so rapidly. Look, the pattern is changing approximately on a 1/10 of a degree level, and our step size was a 1/10 of a degree. So this isn't going to work very well. So why don't we come back up here and we go -9, negative 8.99. So let's go by 100th of a degree. And then we'll do this. And we'll see if that clears up the plot. And there we see, so we just had we had too large of a step size. And so you got to kind of know what you're doing. And then in order to see this thing a little bit better, I'm going to focus here. I want to see things a little bit better. So maybe I'll just go from, whoops. There we go. Axis options. Let's go from, say, 0 to 10. So that'll zoom in vertically. And then maybe let's go here from about 0 to, say, 4. So now you can see what's happening. And this is what I'm saying. There should be a peak right here. There should be a peak right here. And we see this one gets extinguished. Right? I don't know what, it looks like there's some kind of numerical artifact there. I don't know what's going on. You can see these don't exactly reach the bottom. That's again a step size issue. So you could shrink your step size even more. But because this thing is changing so rapidly, that's what we've got to do to clean up some of these little artifacts, I suspect. Yeah, I guess I'll leave it at that. Maybe I'll mention one other thing while I've got this up. And I think, where was it? I think it's on this one. And let me stop my annotation. Whoops, annotation. Let me clear those out. There's something on problem, where is it? I think it's problem 36.9 this will help with. So if you want to pay attention, that's good. Let's get rid of this. I'm going to scroll down to 36.9 somewhere. And if I zoom in here, one of the things that gets tricky, you could see here's one where I zoomed in. You can sometimes get this. So I did a very high precision plot here, and it looks like I've got a bright spot and a bright spot, but really these are two halves of the same bright spot, and then the single slit extinguished it right here. So you can sometimes, it appears like you're getting extra peaks where you shouldn't, and that's because the single slit interference can cut a single peak. It can cut a dark fringe from the double slit interference pattern in half and make it appear like you have two little sub peaks. All right, I'll leave it at that. I think that's good.